Alrighty, folks. We're going to start looking at systems of equations for this unit. Basically just developing them in this lesson, talking about what they are, the different parts, and all the things we're going to need to do. So we'll do that by just starting out with a little bit of an investigation. So cell phone communication dramatically increased in recent years. When purchasing a cell phone, it's important to determine what type of plan works best for you. Considering the following, the two plans, we'll come up with an equation for both of them. So company A, their plan is $80 a month. You get 2 gigs of data, unlimited local calling and texting. Extra data charges are 25 cents per megabyte. Company B, the other one, $100 a month, 1 gigabyte of data, a little bit less, but extra data only costs 10 cents a megabyte. Okay, determine the equation of the pricing, C, of 1 month of company A and B's plan per extra megabyte spent. That variable is M. So they're giving us 2 variables to work with. Now, with both companies, there's a constant cost. You always have to pay for company A $80 a month. For company B, you always have to pay $100 a month. That doesn't change. The thing that does change, the thing that varies, your variable, is going to be that 25 cents per additional megabyte. So using all that information, we can write an equation for both of them. So for company A, its cost is going to be equal to the standard cost we have to pay, the constant, so $80 a month, plus the variable cost. So for every additional megabyte we use, that variable's M, we have to pay 0.25 of a dollar. So 0.25 multiplied by the number of megabytes we use. So this should look very familiar. It looks like slope-intercept form. You could make the cost actually equal to Y. That could actually equal your slope, which was your slope value of M, times your variable, which we used was X. So that could be 0.25x plus your constant, or your y-intercept of 80. So this is basically slope-intercept form, which conveniently we can make a table of values for and then graph. Okay, we could do the same thing for the other company as well. So its cost is equal to its constant fee, $100, plus its variable charge. So plus 0.1 times M, which is going to be, again, in slope-intercept form, 0.1x plus 100. Okay, I got my slope of 0.1. I've got my constant of C. Very familiar y equals mx plus b format. So what we'll do then is we'll graph them, and I've got the table already on my phone, so I can fill them in. So essentially what we're doing here is taking the value of the megabytes, so M, plugging them into this original equation, figuring out what the cost is going to be equal to. So if you plug them all in, each one at a time, you're going to see a cost of 80, 92.5, zoom in here, 105, 117.50, 130, and 142.50. Okay, we chose these numbers deliberately to make the cost relatively easy to graph on here. Even though there's decimals, it won't be too bad because they're all halfway decimals, 0.5. Doesn't make them too difficult to graph. We'll do the other company as well. So those ones are 100, 105, 110, 115, 120, and 125. Oh, excuse me. Okay, so what we can do now is actually take these two different companies, their costs, graph them. Now, we're gonna put both graphs on the same grid. They'll superimpose on each other. That way we can talk about both of them as to what happens. So if you notice this little break in the graph here, a little Z thing, basically what it means is there's no values underneath 70. So essentially if we had them all here counting by 5, so 5, 10, 15, 20, 20, all the way up to 70, there'd be a lot of unused space on that graph. So we just kind of cut it off because we don't need it. So we're going to go graph the black data first, so company A. So their first point was at 0 megabytes and $80. So my cost is going to go always on my y-axis up the side, our dependent variable, if you remember that. So the cost is dependent on how much megabytes we use. So the cost is going to be my y-axis. The megabytes are going to go along our x. That's independent. Cost is dependent. Okay, so let's label this Go start graphing some points. So 0, 80 is the first one. That should be our y-intercept from our equation, just like we said it would be. 50, 92.5. So each of these steps is $5. So halfway is going to be $2.5. So if I can find 90, 92.5 is halfway. So here's my other point, 50, 92.5. So 100 is 105. That's going to be a nice one. 150 is 117.5, another halfway mark. 200 is 130. And 250 is 142.5. So roughly about there. And these points should follow a linear pattern. I know they're not exact, but for the most part, they should be pretty close. So that was company A. We'll do the same thing for company B, plot their points as well. So 0, 100 is our first one. And you can already see we're starting out a little bit higher than we did before. Plot all the other ones, and they go up by 5s. So, ooh, I put that point in the wrong place. That should actually be on 100. There we go. So 50, 105, 100, 110. 150 is 115. 200 is 120. There we go. 250 is 125. So there we go. And again, you notice that linear fashion, that linear pattern. There's my line, company B. Now you notice that these lines intersect one another. They cross somewhere. Okay, we're going to talk about which company we would choose and why. So let's think about this. If I use 0 extra megabytes of data, for company A, I only pay $80, but for company B, I pay 100. So if I'm not going to use any data additional to what I have allotted in my plan, I'm going to pick company A. It saves me $20 a month, saves me a whole bunch of money throughout the year. Company A is the better option. But as I start using data, up until a certain point, company A will always be cheaper. So let's talk about what happens when I hit that point where the lines actually cross. Okay, I kind of circled it in red because it's not exact. It's not really on a grid mark here. But if I use enough data and it looks like it's right around 130-ish, 140-ish maybe megabytes of data, it doesn't really matter what plan I pick because there's a point here that actually exists on both lines. That red point is actually the same on the blue one and the black one since those lines overlap there. If I'm going to use exactly that amount of data, it doesn't matter if I pick company A or B. But if I use more than that amount of data, B is actually cheaper, whereas before, B was actually more expensive. Okay, so just make sure you take a look at that graph and think about that pretty carefully because that's the main idea here. There is one point that will be the same on both lines. And we call that the point of intersection. Okay, so that's our point of intersection or the solution. Okay, so that's also going to be the answer to this system of equations. Now that point has coordinates, let's call it point P, of x and y. Okay, so that coordinate pair of x, y is going to be the answer to this. It'll be the same coordinate pair on both lines. So let's go put all that stuff into words. Okay, so company A starts lower, but ends higher. That's going to be good for those that don't use data. Okay, like we talked about before, if you're not going to use any data, that black line will always be below the blue one. The blue one costs more, black one's cheaper. Okay, so for company B, that one's going to start higher, but ends lower. Okay, and that's going to be good for the opposite type of people. So that's good for those that use lots of data. Okay, so if you're going to use more data than the other plan, so if you're going to use more than that intersection point allows you to, your blue line is going to be underneath the black one. Okay, so that one's going to cost you a lot less. If I look at 200 megabytes, let's say, if I'm going to use 200 megabytes, the blue line will cost 120, whereas the black one costs 130. I'm going to be saving $10 by choosing the other plan. So taking a look at this before you actually sign anything to agree to that cell phone plan, you might want to take just an average of how much data you use. You might end up saving a bunch of money throughout the year. Okay, so here's just a couple of definitions of stuff. So a system of linear equations is when we consider two or more linear equations with common variables. So we could have two equations, variables could be x and y for both of them. Now it has to be two or more, so it could be 3, 4, 5, 6, but each additional equation you add has to introduce a new variable. So if it's 3 equations, you're going to use x, y, and z, or a, b, and c, just 3 variables. It's often referred to as a linear system. For Math 10C, we'll focus on 2 equations with 2 variables. So you'll have 2 linear equations with x, y most commonly as your variables. A solution of a linear system is the pair of values that satisfies both equations. And we'll see this as an intersection point on the graph. Now, if it's a pair of values, it's going to be a coordinate point, or my pair of values is going to be x comma y. Okay. So we'll consider the 2 equations down below. 2x and x plus 2. You can see that solution in 3 different ways. So we got numerically in a chart. I'm going to be looking for the same point on both charts. So I look at the first row. One line has 0, 0 as a point, the origin. The other one is 0 plus 2. Those aren't the same point. That can't be the answer. Next row down, also not the same. But when I get to the point 2 comma 4, that is the same on both tables of values. So my solution here is 2 comma 4. Okay, and if I graph both those lines, I should see that point as well. So that's the point where they cross at. X is 2, 4 up takes me to my y coordinate of 4. So there's my intersection point as well. Algebraic verification. So we're going to learn how to solve things algebraically in the next couple lessons. But I could double check to make sure that the value works inside, which is what we're going to do with that first example. So this person solved the linear system provided. You've got the equations here. There are 2 of them, 2 variables, x and y. The solution is 2, negative 5. Verify algebraically whether or not this person is right. Now, if it says to verify, and they're giving you a point, they're telling you the x value along with the y value. So what you're going to do is take those 2 values, substitute them into your original equations for x and y, and make sure the left side of the equation equals the right side. You're going to check if they're right. So let's go try this out. We'll do the first one in blue. So x minus 2y equals 12. Now you might have seen this before. You can put a little the t-chart to help keep things organized. You really don't need to. Just kind of looks nice. So let's put these points in there. If x is 2 minus 2, y is negative 5, we need that to be 12. 2, that's a negative 2. Multiply it with a negative 5. That'll be a positive 10. That needs to be 12. So when you add them, 12 is equal to 12, and we're good. The other one is what we need to check, because if we're given 2 equations, we should be checking both of them. It seems like I'm good so far, but I don't know for certain until I actually check both equations. Then I'll be 100% certain in my answer. So 3x minus 2y equals 4. That one we need to check as well. So 3 times 2 minus 2 times negative 5 equals 4. So 6 minus, that's going to change to a plus 10. Now I know 6 plus 10 is 16, and that's not equal to 4. Okay, so this one doesn't check out. So if it doesn't work in both equations, it cannot be the solution. So since 2, 5 does not satisfy both equations, it is not the solution. It does not equal on both equations. It cannot be the answer. So it's not the solution. There you go. Okay, it needs to make sure, it needs to satisfy both. Okay, underneath we've got a linear system again. We've got a graph, but we don't know which line is which. So we need to label those first. Now, they're both in that slope-intercept form again. So I've got my x, I got a number in front of it. I have a constant, which is our y-intercept. The easiest thing to look for on those graphs is the y-intercept first. Since those y-intercepts are different, it's going to be real easy to tell which one is which. So whichever one is a positive 3 as a y-intercept, that red line here is going to be my negative x plus 3 because they have the same y-intercept. Okay, so this one is going to be y equals negative x plus 3. That means my blue line is going to be my 3x minus 5. And you can see that negative 5 is your y-intercept as well here. Determine the solution to that system. That's that intersection point which we talked about already. So that's my answer. So my point of intersection here. It's helpful if you state it as well. So 1, 2, comma 1. So x coordinates 2, y coordinates 1. So our solution is 2, 1. Okay, if you don't state that solution somewhere, it makes the person interpreting your work have to guess at what you think the answer is. So please don't make us guess because we don't like that. So just tell us what you think that solution is. Okay, we need to verify it as well, so we'll plug that into both equations again. So y equals negative x plus 3. Let's double check it. Y needs to be 1. So this is going to be, if it's negative x, x is positive 2, so we'll have negative 2 plus 3. 1 is 1. That part checks out. Y equals 3x minus 5. Same thing again. Y is 1. 3 times 2 minus 5. 1 is still equal to 6 minus 5. That's 1. Checks out. Works in both. I'm 100% certain I'm right. Yeah, I've double checked that in both equations. It worked in both. I know I'm correct. Okay, let's go graph a couple of them. So the easiest way to graph a system is to make it into that slope-intercept form, mx plus b again. Now, both of these are not in mx plus b format, so we need to fix that. Okay. So here, I'm going to choose to subtract x on both sides, leaving me with y on the left, negative x plus 8 on the right. Now it's in slope-intercept form, and I know my slope's negative 1. My y-intercept is 8. Okay, we're going to do the same thing over here. For the other one, I don't really care how you move it, as long as you do move it. So I'm going to leave the negative 2y alone, subtract 3x from both sides. So negative 2y equals negative 3x plus 14. But y is not alone yet. There's still a negative 2 attached to it. Now, some people might want to add 2 to both sides, but don't do that. It won't work. These two values are being multiplied with each other. So in order to do the opposite, divide everything by negative 2. So y equals 3 over 2x minus 7. Make sure your signs are correct and they work. Negative and negative cancel to give me positive. Positive, negative, give me a negative. Okay, so let's go graph these now. So in blue, my y-intercept should be positive 8. So here's my origin. So 1, 2, 3, 4. 1, 2, 3, 4. There's positive 8. Plotted correctly. My slope's negative 1. So that's going to tell us we're going to go down 1, right 1. Do that enough times so you get a lot of points that you can graph. Now the other way you could go, following the same pattern, is up 1, left 1. Okay, as long as one of your directions for your rise and run is negative, either you're going down and to the right, right's positive, or up and left. Either way, it makes that nice straight line for you. Now you can connect. And it is a line, so it needs arrows to show that it keeps going in both directions. Okay, so this line is going to be our y equals negative x plus 8. Purple one has to go on as well, so y-intercept of negative 7. 1, 2, 3, 1, 2, 3, 4. There's my y-intercept. My slope this time is positive for both, so up 3, right 2. 1, 2, 3, 1, 2. So from that point that we just created, go up 3, right 2 again. And do it enough times so that you're going to intersect your other line. Right there. One more for good measure to really, really show that, yes, they do cross. Okay, and they cross once at the point that you can see is blue and purple. Okay, that point of intersection, this solution right here is going to be 1, 2, 3, 4, 5, 6, comma 2. Okay, there's my point of intersection. X first, Y second. So I'm going 6 units right, 2 units up. There's the answer. There's my solution, my point of intersection. this is the point that's the same on both lines. Okay, if you want to pause the video and try the next one out for yourself, I'm going to write the answer in there as well, just so you can try it out for yourself. Okay. So here, if we change this equation, it will become y equals negative 2 over 3x plus 1. The other one, y equals x minus 4. Okay, I'm going to graph them as well. So 1, and it's negative 2 over 3, so down 2, right 3. Down 2, right 3. Down 2, right 3. Okay, so here's the first line. This one is my y equals negative 2x over 3 plus 1 line. The other one in green needs to be x minus 4. So negative 4, 1, 2, 3, 4. Negative 4 is the y-intercept. X is positive, so my slope's 1, but it's positive 1. So up 1, right 1. Keep going until you cross, which we do. There you go. Now that means my intersection point, the solution, the answer is going to be 1, 2, 3, negative 1. Okay, so there's my intersection point, the point where they cross. Now you can verify both of these as well, and I'll leave that for you to check. You do have the verification steps in the answer key for your notes, so try them out, and you can do that as well. So this is just the beginning of our systems of equations unit, just talking about what a system is. In the future, we'll get into some problem-solving applications, how to do this algebraically as well. So if you do have those questions, please make sure you're asking your teacher. We are here to help. And we'll see you in the next one.